Hello viewers, I am Kausalya. Today we are going to solve problem number 11 under the topic Routh stability criteria. And the problem is the open loop transfer function of a unity feedback system is given by this expression. Determine the value of k and a so that the system oscillates at a frequency of 2 radians per second. So here the open loop transfer function is given. When you look at the transfer function has two constants. One is k and another one is a. So we have to find the value of k and a so that you see the system oscillates. When will the system oscillate? The system will oscillate whenever the roots are present at the imaginary axis. Right. And finally, they had given the frequency of 2 radians per second. For a frequency of 2 radians per second, the system will oscillate. Right. So, during that time, what will be the value of k and a? Right. So, the first step is we are going to calculate the closed loop transfer function. So the closed loop transfer function is given by the expression C of s by R of s is equal to G of s divided by 1 plus G of s into H of s. Here the G of s value is given in the problem, so we can directly substitute here. When you substitute, this is our G of s divided by 1 plus G of s into, here the value of H of s is 1 because the type of feedback is unity feedback system. Right. The next step is we are going to take LCM. So here this entire term will get multiplied with this 1. Right. So the numerator as such divided by this entire term gets multiplied by 1 here. So 1 plus k into s plus 1 and the whole term divided by this denominator term. Right. So here both the denominators are same. So they cancel each other. And finally we are having an expression as like this. Right. We are having some bigger expression. So this is our closed loop transfer function. Right. So what is the characteristic equation? The denominator term of the closed loop transfer function is known as characteristic equation. So here this is our characteristic equation. Right. So here this is our equation and finally we are going to solve this equation. So the remaining terms you write as such. So here we are having k into s plus 1. So just multiply. K into s, ks, k into 1, k. Right. And the next step is I am just combining the common terms. So s cube, as square. You see here I am having 2s and here I am having ks. So I am combining these two. When I take s outside, the remaining terms are 2 plus k. Right. Plus again this 1 is a constant. Again k is also a constant. So finally writing plus 1 plus k equal to 0. The next step is constructing Routh array. Only by constructing Routh array we can find the values of k and a for the given condition. Right. So here the maximum power is cube. So I have to join all the odd power terms. So s cube and s to the power 1. And the next term is s square and the next term should be s to the power 0. Right. So here it is constant. No need to mention s to the power 0. As we all know, anything to the power 0 is 1. Right. So s cube, coefficient of s cube is 1. Coefficient of s is 2 plus k. Coefficient of s square is a and coefficient finally s to the power 0 is 1 plus k. Right. We have to find s to the power 1. So how to find s to the power 1? A into 2 plus k minus 1 plus k into 1 divided by this corner element a. You see I had written that one. Right. So the next step is finding s to the power 0. So how to find s to the power 0? Again this term will get multiplied by 1 plus k and here there is no second term, so this is 0. So 0 into a divided by again this corner term. Right. You see here I had written the steps. So these two terms cancel each other and finally the answer we are having is 1 plus k. So here I am writing 1 plus k. Finally we had formed our Routh array. So in the problem they had clearly given that the system oscillates. Right. So the system oscillates indirectly means that there is a row of zeros. So we have to find the auxiliary equation and we have to solve for the roots, right? So here you see, we are considering this s to the power 1 as row of zeros. So when I consider this s to the power 1 as row of zeros, what is its auxiliary equation? Its auxiliary equation is the row before the row of zeros. So this term forms your auxiliary equation, right? So I had already told you why we are taking s1 and what is this s square row. So the auxiliary equation will be a s square plus 1 plus k, right? So this forms our auxiliary equation. A s square plus 1 plus k equal to 0. Now we are solving that. So a s square equal to, when you move this 1 plus k to the right hand side, that becomes minus of 1 plus k. The value of s square will be this s, when you move right hand side, occupies the denominator part, and finally the value of s is plus or minus j, because we are having minus term here, that is minus 1. Square root of minus 1 is nothing but j. So plus or minus j root of 1 plus k by a, right? So in the problem they had clearly given the value of root. So the value of s is plus or minus 2j. So here, since both are s values, right, both are roots of this characteristic equation of the given problem. So when you equate those two terms, finally we are getting 2 equal to square root of 1 plus k by a. Once you square on both sides, we are getting the answer as 4 equal to 1 plus k by a. So when you move a to the left hand side, we are getting 4a equal to 1 plus k. So finally, I am finding the value of k in terms of a. So the value of k is, when you move this 1 to the left hand side, that becomes minus 1. So k is equal to 4a minus 1. So to find out the value of a, I am equating s to the power 1 row equal to 0, because we have said that now we are making that s to the power 1 as row of zeros. So here I am equating that term equal to 0. So when you move this a to the right hand side, that becomes a into 0 is again 0. So the next step is, I am moving this minus sign inside the bracket. So minus 1 minus k, right? And the next step is, we are rearranging, that is bringing both the k terms together. 2a minus 1 plus ka minus k. And again, when you take k commonly outside, we are having a minus 1 equal to 0, right? We know that the value of k is equal to 4a minus 1. So just substitute the value in the place of k here. So when you substitute here, I am having an expression like this. The next step is, we have to simplify. So just multiply. 4a into a becomes 4a square. 4a into minus 4a into minus 1 becomes minus 4a. And again, minus 1 into a gives minus a, and minus 1 into minus 1 gives plus 1. So here this minus 1 and plus 1 cancels each other, and here we are getting the answer as 4a square minus 3a is equal to 0, right? So here, when you take a commonly outside, we are getting 4a minus 3 equal to 0. So when you equate both the terms to 0, that is a equal to 0 and 4a minus 3 equal to 0. So here we are mentioning the value of a should not be equal to 0. Why? Because here, when you substitute the value of a as 0, what happens? The first element in the column, the first column becomes 0. So that should not happen, right? So we are equating our second term, 4a minus 3 equal to 0. So here, then finally the value of a is found to be 3 by 4. Now substitute this value of a in the k equation. So when you substitute, here we are getting the answer as the value of k equal to 2, right? Hope you people understand these simple steps, right? This 4 and 4 cancels each other, and 3 minus 1 gives you 2, and the value of k is equal to 2 here. So finally, the result is, the system will oscillate when the value of k equal to 2 and the value of a is equal to 3 by 4, right? Hope you people understand the problem. Thank you.